Math. Pretty nice, huh? Guess who made it? So my math helper here, Ginger. Ooh, got the purr going. Can you hear it? Probably can hear it. Hey, got that light, kitchen light, kind of. There we go. Anyway, let's tilt this up a little bit. I don't want to lose Ginger in the picture. Hey, so today's lesson. Oh, this is an appropriate T-shirt for our life that we're leading. You know what I mean? Think out of the box. Go outside. Grand Tetons, Wyoming National Parks. I already wore this shirt once before for you. Anyway, averaging, mean, median, mode, range, measures of central tendency. That means where do the numbers tend to fall? Where do they tend to go? Where are they tending to be? And that's what measures central tendency do. And so we see this data analysis all over. And by golly, I've been saying a lot lately with this, the COVID numbers and so forth, and the numbers moving around and talking about mathematics is so vitally important right now. But I do want to say that, do you see that cat tree back there? Okay. Angle better. There we go. Sorry. There's a cat, my little helper, my Ginger helper. Her name's Ginger. Do you know that? So this is a line graph. Now, hopefully you've all seen these before, but it's a way of showing the data set, kind of like a bar graph, kind of like any kind of line or dot plot. And what's nice is it's really easy to look at this and go, okay, there's 1/6 in my data set. And what do these numbers mean? I'm going to tell you right now. Can I write it up there? Probably not. We're going to call these quiz scores. Quiz scores, okay? The reason I'm using this is because it's really simple, right? Because we're going to, out of possible 10 on any quiz that you get, let's just pretend we're making this up for the sake of explaining mathematics and measures of central tendency. This is how the data set plays out. So let's say, first thing I want to consider is, how many pieces of data do we have? I'll count it for you. Count with me if you'd like at home. 1, 2, 3, 4, 5, 6, 7, 8, 9 pieces of data. Now, let's verify that I have 9 x's too. 1, 2, 3, 4, 5, 6, 7, 8, 9 x's plotted above. And we can see that the mode is the most common number, the number that shows up the most often. What is the mode in this data set? You can see it quite obviously there. That's the mode. Okay? Okay. The median of a data set. The median, here's how I can help you remember the median. The median of a data set is the middle of it, the middle number. So in order to figure out the median, we would have to line up our data set. We have 9 pieces of data, which is an odd number. That means we're going to have an absolute middle. Okay? So the median's the middle. You know, the one way to remember that is down Esplanade, our town, over there by Chico High. That strip of concrete and plants that go down the middle is called the median. So maybe that'll help you down the middle. The median. So in the case of this data set, we line up our data and a couple 9s and a couple 10s. Okay? So now which one is the exact middle of this data set? And there's a couple ways you can do that, cross off as you go. If you can't, just figure it out really easily. And as we go, there it is. So the median of the data set is also a 7. Isn't that right, Ginger? Yes. Ginger agrees. The median of the data set is a 7. Now, it just happens to be the mode also. It showed up a lot, but imagine if that was a different number, then it wouldn't be the mode. Okay. Now we want to figure out the mean or the average of a data set. The mean. Not that you're being mean unless you just are mean about mathematics. Ain't that right, Ginger? Okay. The way you figure out the mean, oh, she's gone now because I was being mean. You get it? It's not true at all. Is you add them all together and you divide by how many data pieces there are. This is how it's always done. So we add them all together and we get 72. You can check my math if you want, but I'm pretty sure. A couple ways to do this strategically. I quickly went to the tens, put them together, get 20, 29, plus that's 38, plus the 7 here is going to be 45, 52, 59, 66, and 72. You could also put the 4 7s together for 28. That helps you. Make sure you get them all, but you get 72. And then how many pieces of data? We already decided there's 9. So we're going to have 72 divided by 9. And that is our mean. That's our average. Do you know your math facts? God, I wish you knew your math facts. It's so tough. It's what? What is it? What is it? What does that equal? 8. So our mean is 8. Now here's the interesting part, and I purposely set this data set up this way. Here's an interesting part. As you'll note, there is no 8 in our data set. And yet the average of this data is 8. See? So that sometimes happens. And so you'll see this often with other pieces of data like people. And you'll see 1.8 persons on average entered the water park per hour or whatever, something like that. And you're like, 1.8 people? What do you mean 0.8 people? What do you mean 80% of a person? And that's how those numbers come up. That they're not really the exact number in the data set. It's the average. And for example, I was just looking at your pollinator quiz from that we did yesterday, and it at the time I looked, about half of you have taken it, read the website and taken the quiz, and we had a 14 point, I think it was 14.6 average. Okay, so that's a good example. You can't get 0.6 of a point on that. You had 15 points possible, but because enough people missed, some kids got 13. So I think the worst I ever saw was the 13. So that's pretty good, 13 out of 15. How do you figure out that? As it comes down to division. We've done long division before, haven't we? Quite a lot. So having just said that, here's what we're going to do. We're going to now take this practice and throw a little something at you. So let's say that we have just, I'm going to go with a quick 4 pieces of data. What is it? It's how many 8-ounce glasses of water you drank for Monday, Tuesday, Wednesday, Thursday, and Friday. So let's quick. Did I say 4? I meant 5. And let's say 8 ounce is a glass of water. I don't know if you know that's a cup. 8 ounces a cup. 16 ounces a pint. So we're going to say 8 ounces. And how many 8-ounce glasses did you drink per day for a week? Okay. So let's just throw some data down really quick. I have no idea what this is going to add up to, but I'm going to do that. So 5 of those, how many ounces would you have drank? 40 ounces, right? What's that? That's probably shouldn't right up there. 40 ounces. But we're not. This is cups of water. Does that make sense? Cups of water. And we could say, well, how many ounces is that? Well, it's 64 ounces. Okay. Which, that might sound like a lot to you, really, but this is about a pint. So this is actually, it's bigger than a pint. It's closer to a quart, but anyway, it's about a pint and a half, right? What is it, Audrey? Gosh. Okay. So let's figure out. First, if we look at this data set, you can quickly see the mode. What is the mode? What is the mode? What number shows up the most? The mode. It's 5. Okay. What's the median? I don't know. I don't know what the median is. So let's line up our data set in order. 5, 5. This is important. You have to do this to figure out the median. 7, and 8. And so our median is 6. And then what's the mean? Okay, we need to add them together and divide by 5. Now, the other thing is we have range. I didn't really mention on the previous thing. Range is just really how spread out the data is. That is the biggest number minus the smallest number. The range often tells us the complete spread of the data. And perhaps we have an outlier, a number in there that's just, it's crazy. Shouldn't even be in there because maybe one day we did it wrong and we put some huge number like 32. We meant ounces, but we ended with cups. Does that make sense? So we want to watch the range of data too to kind of make some good decisions too. But in this case, it's a clean cut. So our range here is 3 cups, right? 8 minus 5. Now, what's the mean? What's the average? Let's go. 5 plus 5 is 10. Plus 6 is 10 plus 6, and then 16 plus 7. 16 plus 7 is 23. And then 23 plus 8 is 31. Does that sound right? 31 total. Is that right? Let's do it again. Let's work backwards. 15 plus 10 is 25 plus the 6. Ooh, see how I did that? Just gonna make it. Those numbers kind of play easy. Okay. All right. We call it compatible numbers, by the way, when you can move stuff around and make it a faster math problem for yourself. Okay. 31 divided by 5. Now, at first you're going to go, well, that's not a math fact. No, of course it's not a math fact, but you know how to do division. And we've done it with fractions. We're going to do it with decimals too. Let's do it both ways on this. 31 divided by 5. We know that 5 times 6 is 30. Place value, place value, place value, place value. Your 5 is not going to 3, it's going to 31. So the 6 is above the 1. Okay, we're going to have 1 left over. So we can relay that as 6 and 1/5. Again, the divisors are 5, so our denominators are 5 here. 6 and 1/5. That's our mean. A little bit more than 6. That's because 8 and 7 kind of pull those 5s up a bit, right? Or we can do a decimal. The way we do the decimal is put a decimal behind the 31 and put a 0 in and bring down a 0. And then put a decimal up here behind the 6. So the decimals go straight up. 5 goes into 10 2 times. So 6.2, which 6 and 1/5 is 6 and 2/10. I just renamed that with the magic 1 of 2 over 2, which 6.2 is 2 in the 10th spot. Okay, so our mean is 6.2. Got it? Average amount of cups of water you drink in a week in this particular example. Okay, so that's how you figure out measures of central tendency. Got it? Okay, measures of central tendency. Where do the numbers tend to fall? And what numbers tell the best story about that data? And we should then analyze that data, which is what statisticians do, to make sure that the numbers are telling the best story possible. Okay, but don't be mean. Okay, be kind as you figure out the mean. Get it? Because the mean, you don't have to be mean. You should be kind when you do the math. Okay, ta-ta for now. Bye, Ginger.